In this video, we are going to discuss De Moivre's theorem, LAQ, PYQ. Very important problem, many times repeated. If alpha, beta are the roots of the equation x square minus 2x plus 4 is equal to 0, then for any small n belongs to capital N natural numbers, show that alpha to the power of n plus beta power n is equal to 2 power n plus 1 into cos of n pi by 3. See here, what is given? Alpha, beta are the roots of the equation x square minus 2x plus 4 is equal to 0. First, what is the given equation? See, given that here x square minus 2x plus 4 is equal to 0. See, for this quadratic equation we have no factors. So that's why here, so a is equal to, if you compare with ax square plus bx plus c, a is equal to 1, b is equal to minus 2, c is equal to 4. Now here x is equal to minus b plus or minus root over b square minus 4ac by 2a. So now what we get from this? So which is equal to x is equal to minus b is minus 2 plus or minus root over b square, that is minus 2 whole square, and here minus 4 into, so a is 1 and c is 4. C is 4. So whole divided by, so here 2 into a is 1. So which is equal to, x is equal to, we get here, so 2 plus or minus root over, so this is 4 and here minus 16 whole divided by 2. And again x is equal to here 2 plus or minus, this is root minus 12 whole divided by 2. So now what we get here, so x is equal to, so 2 plus or minus, so this is, we can write 12 into minus 1, 12 into minus 1, so whole divided by, so 2. We know that here I square is equal to minus 1, so that's why it can be written as x is equal to, so 2 plus or minus root over, so this is 12 into I square, this is whole divided by 2. See, further we can write it as, see, x is equal to, so root x is equal to 2 plus or minus, so here root 12 can be written as 2 root 3, and here root I square is nothing but I. So root 12 I square can be written as I into 2 root 3, so whole divided by 2. Now x is equal to, if we take the 2 common here in the numerator, so which is 1 plus or minus I root 3 by 2. So 2 gets cancelled. Now x is equal to 1 plus or minus I root 3 we get. See here, what is given here? Alpha, beta are the roots of the equation. Now here we have two roots for x is equal to 1 plus or minus I root 3. So alpha is equal to, let alpha is equal to here 1 plus I root 3, and beta is equal to here, beta is equal to 1 minus I root 3. So suppose if you take like this, now considering alpha is equal to, now alpha is equal to 1 plus I root 3. So now simplifying, here also this is multiplying and dividing by 2 here, 1 plus I root 3 whole by 2. So here 2, if you separate the, if you split the denominator, then we get 1 by 2 plus I into root 3 by 2. I into root 3 by 2. So see here alpha is equal to, so 2 into, see in terms of cos we can write this is a cos 60, that is pi by 3, plus I into root 3 by 2 in terms of sine. So sine 60 we know that. So this is 2 into cos pi by 3 plus I sin pi by 3. Now here what is given? Alpha to the power of n. Alpha to the power of n is equal to, now 2 into cos pi by 3 plus I sin pi by 3, I sin pi by 3 whole to the power of n, whole to the power of n. See, if you apply the De Moivre's theorem, so here alpha power n is equal to 2 to the power of n. For this, if you apply the De Moivre's theorem, cos theta plus I sin theta whole to the power of n, we know that cos n theta plus I sin n theta. So as per that, this is also cos n pi by 3, cos n pi by 3 plus I sin n pi by 3, cos n pi by 3 plus I sin n pi by 3. We know that the De Moivre's theorem, cos theta plus I sin theta whole to the power of n, so which is nothing but cos n theta, that is n into pi by 3, plus I sin n theta, that is n into pi by 3. So here finally we get 2 to the power of n into cos n pi by 3 plus I sin n pi by 3. Now what is beta here? Beta is equal to 1 minus I root 3. Same like this we can write. So similarly beta is also is equal to, we can write, so beta is equal to, now beta is equal to, so we can write beta is equal to, we have 1 minus I root 3. So see here 1 minus I root 3, this is, so beta is equal to, we can write similarly, beta is equal to same like alpha. So what is the difference here? 1 plus I root 3, here 1 minus I root 3. So which can be written as, similarly beta is equal to 2 into cos pi by 3, cos pi by 3. So here minus I sin pi by 3, minus I sin pi by 3. Like this we can write beta is also. See here, so beta power n is equal to, now beta to the power of n is equal to 2 into cos pi by 3, so minus I sin pi by 3, minus I sin pi by 3 whole to the power of n, whole to the power of n. So now which happens, beta to the power of n is equal to, here 2 to the power of n, and here also what we can write like De Moivre's theorem, here we can write cos of minus pi by 3, minus pi by 3, and plus here I sin of minus pi by 3, I sin of minus pi by 3 whole to the power of n. See, cos of minus theta is always cos theta, we know that. Sin of minus cos of minus theta is equal to always cos theta, and sin of minus theta is always minus sin theta. So theta lies in the fourth quadrant. So like this we can write cos of minus pi by 3, which is only cos pi by 3. Now finally beta to the power of n is equal to 2 to the power of n into, so if you apply the De Moivre's theorem, we get cos of minus n pi by 3, and here plus I sin of minus n pi by 3 if you apply the De Moivre's theorem. See, did you get? So now this is beta to the power of n. We have beta to the power of n is equal to, so 2 power n into cos of minus n pi by 3 plus I sin of minus n pi by 3. So what is given here, LHS, we have LHS is equal to, LHS is alpha to the power of n plus beta to the power of n. So which is equal to, alpha to the power of n is, we have 2 power n, so 2 power n into cos of n pi by 3 plus I sin of n pi by 3, I sin of n pi by 3. Similarly, plus beta to the power of n is, we have 2 power n into, so 2 power n into cos of minus n pi by 3, minus n pi by 3 plus I sin of minus n pi by 3. So we have beta power n. See, observe here. Now in both the terms we have, so 2 power n is common. If you take 2 power n is common, so we get here cos of n pi by 3 and plus I sin of n pi by 3. I already told you here cos of minus n pi by 3 is also only cos n pi by 3, and here so plus I sin of minus n pi by 3, that is sin of minus theta is equal to here minus sin theta. So we can write minus I sine of n pi by 3. See, as per that property. See, observe here. So, plus I sine n pi by 3 minus I sine n pi by 3 terms gets cancelled. So, now we have here 2 to the power of n into cos n pi by 3 and cos n pi by 3. So, we get 2 cos n pi by 3. So, here which is equal to 2 power n into 2. So bases are equal, we can add the power. So which becomes 2 to the power of n plus 1 into cos of n pi by 3. Cos of n pi by 3. See, we get here 2 power n plus 1 into cos of n pi by 3. Finally, we can write therefore alpha to the power of n plus beta to the power of n, which is equal to, so 2 power n plus 1 into cos of n pi by 3. Cos of n pi by 3. So like this we can prove the given problem by using the De Moivre's theorem.